All right, so today we're going to talk about inscribed angles. Everybody else good? All right. So at the beginning of this chapter, we talked about a lot of central angles, right? We talked about with central angles, your vertex is on the center of the circle. Today we're going to talk about inscribed angles. And inscribed angles and angles whose vertex is on the circle. Okay, so our inscribed angle, the vertex is on the circle. The vertex is on the circle and the legs are chords. The legs are chords. With our central angle, the vertex is on the center. And then the legs were radii. So we're focusing on where the vertex is. If it's on the circle, it's called an inscribed angle. Inscribed meaning like inside. Okay? And then if the vertex is on the center, it's called a central angle. So most everything we're going to focus on today is due to, or all the properties we're going to look at are because of inscribed angles. Okay? So the relationship between the inscribed angle and the arc that it intercepts is that the angle is half of the intercepted arc. So for instance, if this is 90 degrees, if this arc is 90 degrees, my angle has to be half of that for 45 degrees. Now I'm going to ask you to take my word for it that this is true. We're going to prove this on, I don't know, my syllabus got all messed up because of the snow day. I don't know, it's next week sometime, I think, or maybe the week after. It takes about 30 minutes for us to prove this. Really? It does. It's an intense day. It's an awesome day. I'm sure you'll love forever and ever. But it takes about 30 minutes to go through this proof of why inscribed angles are half the intercepted arc. So for today, I'm going to have to ask you to just trust me, and then I'll prove it to you why that is. So I can do that. Well, thanks. Well, I try to back up what I say with logic and proofs, but that's all right. But thanks for believing me. Okay, so the angle is always half of the intercepted arc. So everything we're going to talk about today is going to build from there. Okay, so the next thing is, if you have two inscribed angles that open up to the same arc, then the inscribed angles have to be congruent. Okay, so we have this blue angle here that opens up to this 80-degree arc, right? The blue angle here opens up to this 80-degree arc. This red angle also opens up to this 80-degree arc. We just learned that inscribed angles are half of the intercepted arc, right? The measure of the inscribed angle. So if they're both opening to an 80-degree arc, then they're both going to have to be 40 degrees. Okay, so that makes sense logically. So therefore, if you have two inscribed angles that open to the same arc, then the angles have to be congruent. Is that right? Y'all look exhausted. It's been a long day. It's been a long day. It's only our third day. It's the longest 3-day week ever. Yes. That's fair. All right. We have 3 more we're going to talk about, and then we're going to just practice with them. Okay? The next one says if you have a right angle, an inscribed angle that is a right angle, then it's going to open to a semicircle. Or we can reverse it. We can say if you have an inscribed angle that opens up to a semicircle or a diameter, then that has to be a right angle. So let's think through prove this, why that is logical. So first of all, I have an inscribed angle, right? Because the vertex is on the circle. I have a diameter here. So this then becomes a semicircle. What's the measure of every semicircle? 180 degrees. We know that the inscribed angle has to be half of the intercepted arc. So what's half of 180? 90. So if you ever have an inscribed angle that opens up to a diameter, then you know that it's going to be a right angle. Or if it opens up to a semicircle. Does that make sense? All right. Okay, our next one deals with something called a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral that's inscribed in a circle. So the four vertices of the quadrilateral are on the circle itself. Okay, so if you have a cyclic quadrilateral, then the opposite angles are supplementary. So angle 1 plus angle 3 is going to be 180. Angle 2 plus angle 4 is going to be 180. So let's think about why this is. We're going to focus on angles 1 and 3. We can do it for angles 2 and 4, but we're just going to focus on 1 and 3. Okay, so I'm going to look at angle 1. If I follow the legs of angle 1, it opens up to this arc, right? Okay, angle 1 is an inscribed angle. So whatever that arc is, angle 1 has to be half of it, right? Now let's focus on angle 3. If I follow the legs of angle 3 out, this is my intercepted arc. Right? And I know angle 3 has to be half of that green arc. Well, how much of that circle did I just highlight? The whole thing, right? So I have 360 degrees that I've highlighted. So what's half of 360? 180. So that's why the opposite angles are going to be supplementary. Is that okay? I can do the same thing for 2 and 4. 2 and 4 are just going to open up to 2 different arcs, but it's still the whole circle. See, math is so beautiful, so logical. It all comes together. Angels start singing. Sun starts shining down on us. All right. Any questions on that one? Okay, the last one is dealing with parallel lines. So if you have 2 parallel lines that intersect a circle, the circle then, or the parallel line, has congruent arcs. So the arcs between the parallel lines are congruent. Not above, not below, but just between the parallel lines. I'm going to talk through this proof a little bit too. But that day when we start proving it, the inscribed angles, we'll prove all of these as well, like formal proofs. I know you're really looking forward to that day. So these are my parallel lines. I'm going to draw in a transversal. If I were to draw in a transversal, and I have parallel lines, remember that that makes all those special angle pairs. So I actually have alternate interior angles. Right? So if these 2 angles are congruent, then their intercepted arcs are going to have to be congruent as well. Right? Because we know that this is, whatever this angle is, it's half of this arc. Same thing is true here. This angle has to be half of this arc. So if the angles are congruent, then my arcs are going to have to be congruent as well. Yes? Sorry, say that again. Not necessarily, because what can happen is what if I did this? Those are these are parallel lines. Those necessarily guarantee top, half, and the bottom are going to be exactly the same. Does that make sense? Okay, so yes, just the arcs in between the parallel lines. Good? All right, so now we are just going to practice with all of those conjunctures. Kind of put them all together. So, okay, I'm going to do the poll. Do you want time to kind of work through all of these and then we go over them, or do you want to do one at a time?
We do one together and then we come off the rest of it.
Yeah. Yeah, we can start with one. We'll start with one together. All right, so do you want to, I'll give you a minute to look at this one first. Okay, you're trying to solve for those three values over here. I'll give you a minute to think through it, and then we'll talk about it.
So I'm just kind of confused on
So if you were to literally trace the angles with your fingers, like if here's my vertex, if I trace it, it's the arc between my fingers. Same thing here. If I follow the legs, when it hits the circle, the arc between my fingers. Or like here, if I trace the legs of this right angle, it's the arc between my fingers.
Okay.
Does that make more sense?
Yeah.
Okay.
Thank you.
Sure.
Do you have enough time for the first one?
Yeah.
Okay, so a lot of times I try to figure things out and then I go fill in the blanks later. But I see I have an arc of 80 degrees. I can see I have an inscribed angle, so this angle has to be half of that, or 40 degrees. I also see that I have a diameter here, which means I have a semicircle on each side. So if this arc is 80, this arc over here has to be 100. So let's figure out, what do we need to know? Let's see, X and M. So that angle is 40 degrees. Arc XN is a semicircle. That has to be 180. And then MN, we labeled as 100. Is that okay? All right, why don't you try the next one now? Would anyone like more time? Yeah. Are we good? All right, so for this one here, I see 120 degrees. I have the central angle that opens up to that, so that central angle must also be 120. I also have this inscribed angle that opens up to that 120 degree arc, so it has to be 60. I notice these three angles here form a line, so they have to add up to be 180 degrees, so this becomes 60. Okay, so now because these three angles are equal, then the arcs are split evenly. So each of those arcs is going to be 120. This is kind of a weird situation too, where you have a tangent and a chord here that make an angle. So it acts like an inscribed angle because the vertex is on the circle. So the angle ends up being half of the intercepted arc. It's kind of a weird situation, but that's what happens. Okay? Questions on that one? All right, why don't I give you, let's go maybe 5-10 minutes here to work through the rest. Like, just keep plowing through. There's a big one on the back. I kind of made big so you could draw all over it. Okay? So you keep working through, and I'll give you a couple minutes to look through them, and then we'll start going through them together.
Give you about 2 more minutes here.
If you're stuck on the back, remember that radii need isosceles triangles. So now you see it.
So is the F this single here or this?
Because this is the ruler.
Oh, yeah. Thank you, I appreciate it.
All right, let's talk about what you have, so we don't run out of time here. All right, so for number 3, you have 3 inscribed angles, right? You have a triangle and a circle, but you really have 3 inscribed angles. So angle C here has to be half of this 70 degrees. So we know that has to be 35. Angle A is opening up to this diameter, which means that it's 90. Okay, then you can either get angle B because it's a triangle and you can take 180 minus 90 minus 35. Or if this is 70, because this is the diameter, this part has to be 110. So B has to be half of 110 because it's an inscribed angle. So it has to be 55. Is that okay? Next one is very similar to that. Okay, so angle A is an inscribed angle opening up to the 100-degree arc there, so this has to be 50. C is opening up to 140. That has to be 70. And then you can either use your triangle or you can figure out your missing arc here, right? So this has to be then 60 degrees. Is that one okay? All right, next one. Next one. So this is one of our problems from yesterday. I think it was yesterday. This is my kite, right? We know those have to be right angles right here, so these 2 angles are going to be supplementary. So angle X has to be 140 degrees. Okay, next one. We have a tangent and a diameter or a radius intersecting. So I know I'm going to have a right angle right here. Okay, then I can use my triangle to figure out that this angle is 36 degrees. So if this inscribed angle is 36 degrees, this intercepted arc has to be twice that. or 72 degrees. So let's see, angle A, we said is 90. AB, we just figured out is 72. Angle C, we just figured out is 36. So then CB, because this is a diameter, that makes this a semicircle. So 180 minus 72 gives me 108. Is that okay? All right, next one. Okay, so I can find my missing angle here. If this is 80 and 70, that's 150, so that makes this angle here 30 degrees. You want to know? Okay, so then arc AD, you can actually go through and figure out all your arcs first. So if this is 70 degrees, I know this arc has to be 140. If this angle is 30, then arc AB has to be twice that, or 60. And then if angle, this 80-degree angle here opens up here, that has to be 160. So let's answer our question. So AD is going to be 140. Arc AB is 60. And DAB, got to go the long way around, right? That's 140 plus 60, that's 200. I know I'm going the long way around because it has three points, right? That makes it a major arc. Good. Questions on that one? Yes.
Can you go back to 6 real quick?
Sorry. Good. All right, number 8. Number 8's a good one. So notice that this angle here and this angle here open up to both, they're both inscribed angles that open up to arc R. So those two angles are going to have to be congruent. So I know this also has to be 29 degrees. That makes my arc twice that value, or 58 degrees. Okay, now, if this is 87, this vertical angle here has to be 87. Then I just use my triangles, and I got 64 degrees here and here. How do I get 58? Because this inscribed angle opens up to this arc. So this arc has to be twice the angle. Is that okay now? Okay, good. So now I know all three of my angles. Okay, so I notice here I have this inscribed angle opens up to P. So I know that has to be 128. Okay, now I have two congruent chords here. I have two congruent chords, which means these two arcs, S and Q, are going to have to be congruent. So I took 360, subtracted my 128, subtracted 58, and I came up with, so there it is. I came up with 174. Now I can take 174 and divide that by 2, and that's how I got 87 for both S and Q. Is that okay? Yes. Okay. You got this angle right here. So you got 93 and 93. Okay, but the problem is this would have to be on my center of my circle. It's not a central angle. Does that make sense? Other questions? That's okay then? All right, so now we're at the big guy in the back. All right, so this one here, first thing I started with is I looked for my isosceles triangle because I have radii. So if this is 25, I know this has to be 25. So now I can use my triangle. This makes angle E here 130. Then I did the same thing down here with this triangle. My base angles are congruent, so then I can find angle C. Then what I did was I used my linear pair here with E and A. I know A has to be 50. I have a vertical angle now that has to be 50. You could also use, so here we have these three, D, C, and D, you have to add up to 180. You can get 50 there. So now we have a whole bunch of central angles, right? So D is 50, N has to be 50. Because of my parallel lines, I also know H has to be 50, or I could have gotten it from my central angle here. So we have tangent lines here. Tangent lines and radii intersect to form right angles. A radius and a tangent line intersect to form a right angle. So I know that these two angles, 50 and K here, have to add up to be 90, so K has to be 40. C here, because this is an 80-degree central angle, N has to be 80. Where we have G still. G is this arc, so if A is 50, G has got to be 50. And then P up top, if its central angle is 130, P has to be 130. Yes.
So how do we figure out that H is 50? Like I don't know.
Because I have a central angle right here. That's 50 degrees, so the central angle and the arc have the same measure. I can also tell because here's my parallel lines, and they have to cut congruent arcs.
Okay.
Yes.
Yeah.
Does that make sense now?
The H was just the inside, so that I was confused.
Yeah, it was just not enough room to squeeze it in
Yeah.
here. All right, questions on any of that? Okay, your homework is out of your book this weekend. I did make a copy of it in case you don't want to find your book. Or the nice thing is you can draw all over this paper, not necessarily the book. Okay. All right, so your homework is front and back of that, the 1 through 16 and then the 22. 1 through 16 and 22. So I know that this is a little bit more homework than I typically give. The problem is once you get into these figures, like it's not like you're doing 16 of the exact same problem. You know, so it's hard to cut back on some of these. So do your best and we'll figure it out enough of it, okay? Yeah, you can. Use your finger.
That's just a few.
The circle.
Yeah.